Good evening, ma'am.
Good evening, Peter. Audible? Is I audible?
Yes, ma'am.
Okay, fine. I hope you have solved yesterday's question.
Yes.
Do we have to discuss those questions or shall I move ahead?
I have doubt in those.
Which question? Can you dictate the question so I could write it here? Or else it is in test only?
It's in test one.
Which formula?
Ma'am,
I'm not able to hear you. If you write it, that would be better, or else you tell me. Hello, are you there?
ma'am, the test questions I can't see.
You're not able to see the question. Fifth one. Let me know the question, please.
Ma'am, the test questions like everything once can you explain?
Okay, all questions I should.
Yes, ma'am.
I don't know which questions I gave yesterday. Then I got few questions, some of that only few questions I gave, I guess. Okay. So I hope I have given you this question. The question is, if mass of one atom, right, is 3.32 into 10 raised to minus 23 gram, right? Then calculate the number of nucleons. Correct? Yes or no?
Yes, ma'am.
Present in two atoms of element. I am also giving you more the option, and the options would be 40, 20, 10, 30, and next like that, correct? I'm not going to write that, just calculate thoroughly. So mass is given for the one atom. One atom has a mass 3.32 into 10 raised to 53, correct?
Yes, ma'am. So two
So
atoms.
ask
Two.
you what? Calculate the number of nucleons. What they ask you to calculate? Number of nucleons. Now you should be aware by the nucleons. What do you mean by nucleon? Tell me.
Ma'am, it's atomic number equal to 9. Ma'am, the negative
Nucleons.
charge. Negative.
Nucleons means number of neutron and the proton present in the nucleus of an atom. Correct? Yes or no?
Yes, ma'am.
Yeah. So you have to calculate it. If you calculate how many nucleons are present in one atom, you have to later multiply it by 2. Correct? Yes or no?
Yes, ma'am.
Yeah. So they have given you the molar mass of element. Okay. So molar mass, how you are able to calculate? Can you tell me? If you have a number of particles. What we know, mole is equal to given particles
6.022.
upon Na, right? Yeah.
Yes, ma'am.
Yes or no? The number of moles of the given particle is 3.32 into 10 raised to minus 23 upon 6.023 or 22 into 10 raised to 23, 23 plus 23, correct?
Yes, ma'am.
Yes or no?
Yes, ma'am.
Now what you have to do? What you have to do? Mole is nothing but what? Gram molar mass of that particular atom. Correct? gram molar mass of any atom is nothing but the mole, right? So mole is nothing but gram. So if left and right side is same, we can say that gram molar mass is nothing but what? 3.32 into 10 raised to minus 23 on 6.022 into 23, correct?
Yes, ma'am.
Hmm?
Yes,
Yes or
ma'am.
no?
Yes, ma'am.
How you have to calculate now gram molar mass? By dividing or by multiplying? Gram molar mass, when you, whatever given mass would be there, that you divided by what? Avogadro's number. That time you will get the particle, isn't it? You
Yes,
need
ma'am.
to multiply these two now. How you will get gram molar mass is equal to, I'll write it here, you will get the clear idea. Fine. Wait a minute. Right? So mole is nothing but the gram molar mass. So you will get what? Molar mass of element is equal to this given particles 3.32 into 10 raised to minus 23. This is a mass of one atom multiplied with 6.022 into 10 raised to 23. Because one mole has a mass, one mole has a particle 6.022 into 10 raised to 23. And total number of total mass of that atom is nothing but 3.32 into 10 raised to 23. So molar mass is nothing but 3.32 into 10 raised to 23 multiplied by 6.022 into 10 raised to 23. Okay, this is for the mole and this is for the molar mass of the element. If you multiply these two, what you will get? When you multiply, these two will get add. So plus minus get cancel. Correct?
Yes, ma'am.
Yeah. So 3.30 into 6.02 would be the answer to this. Tell me the approximate value. Do this calculation. Can you do that? 3.32 into 6.022.
Yes, ma'am.
Ma'am, why do we use for molar mass the mass of one atom into like the Avogadro's number?
Yeah, that is Avogadro's number. What I said you, this is about molar mass of element. This is about the mole.
Okay.
Okay.
So why do
This
we
number of moles we can calculate by this number of moles. Here we don't have to calculate the number of moles. We are going to calculate the molar mass for the element. For that, what you have to do, you have to take, sorry,
19.9 approximately.
19.9.
9. I'm 20 approximately.
It's approximately 20, correct?
Yes, ma'am.
Yeah, this is for what? One atom. Means in one atom, how many nucleons would be there? 20. So in two atoms, how many?
I'm 40.
40?
Yes, 2 into 20. That is equal to 40. It's given in your, this one, I guess. Option. Check it.
Yes,
Is it
ma'am.
given?
Yes, ma'am.
Yeah, so that would be the answer. How you have to calculate the molar mass of element? Taking the given factor, multiply with the Avogadro number, you will get the gram molar mass, okay, for one atom. And how many atoms they have given? Two atoms only. So 220 is equal to 40. Clear?
Yes, ma'am.
Yeah. Any query?
No, ma'am.
Just
I'm clear.
okay, fine. What was the next question? Can you please tell me? Then that will be easy, I guess, to solve. Actually, I don't remember the questions because yesterday I kept the PDF, but then the day before yesterday PDF was there, but then yesterday I have typed those questions directly in the system. So I can't open it right now. Do you know? The next question was this one?
I attempted the test, so I can't open it again.
You did give test?
Yes, ma'am.
Okay. So was it this? Total number of electron present in 48 gram of Mg2 plus R? No, no. The platinum anti-cancer drug is I gave you the
One question was regarding the latest 24.
Aspirin.
Yes, ma'am. Yeah.
Aspirin tablet. Okay, fine. We'll check it. Okay, or similar kind of questions I'll take. So that will help you to solve those questions. It won't be problem, correct?
Yes, ma'am.
Yeah. So write down the next question. Because today I have to give you knowledge about the empirical formula and molecular formula as well, because that is also one of the important part of your chapter. Number of questions would ask on it. Okay. Write down the problem. So the problem is aspirin has the formula. Aspirin has the formula they have given, that is, I think, C9H8O4. Okay. How many atoms of oxygen are? Atoms of oxygen are there in a tablet weighing 360 mg. In the tablet weighing 360 mg. So how are you going to solve this? Just one, Preetam, Vedic.
Ma'am,
What you will do?
granular mass of aspirin 80 grams. So in
You
360.
have to calculate the super molecular weight, correct?
Yes, ma'am.
So how you will calculate it? Molecular weight for the aspirin you calculate.
Ma'am, it's 180.
How much?
180.
I guess it would be, I think, by calculation we will get molecular mass of 9 atoms of carbon plus 8 atoms of hydrogen plus 4 atoms of oxygen. Correct? 9 into 12 plus 8 into 1 plus 4 into 16. Do this calculation. I hope it would be around
Ma'am, it's 180.
180.
80.
Are you sure?
Ma'am,
Okay, fine. You have calculated it will be 180, correct? This is a molecular mass. Now you have to calculate the number of moles. How you will calculate number of moles?
now I should divide it by Avogadro.
Gram molar mass, whatever mass is given. They have given you mass what? How many grams? 360 milligrams. If I have to convert it into grams, what it would be? Because volume is given into milligrams. We should convert it first into grams, correct? So 360, right? Given mass, number of moles is equal to given mass upon gram molar mass. This is unified mass or AMU we can say. Then when you express into the gram, it becomes gram molar mass. Correct? That is become now 180. It is 180 gram. This would be what? Gram molar mass. Correct? So given mass is nothing but 360, but then that is into milligram. So if you have to convert it into the kilogram, that you need to multiply by 10 raised to minus 3. Correct? Yes or no? Do you know why I have multiplied by 10 raised to minus 3? Because 1000 gram is equal to 1 gram.
1.36 gram.
We know. And what else? Here what they have given? Gram molar mass is given, that is into the gram. It's milligram we have to convert into gram. That time we need to multiply by 10 raised to minus 3. And now your molar mass is nothing but 180. Okay, so what number of moles will equal to how many now?
And 2.
2 into 2 into how many? 10 raised to
2 raised to 3 minus 3.
minus 3. Correct. Okay, fine. So you get this. This is a number of moles. You have a molecule C9H8O4. They have given a 360 mass. Number of moles are given. In one molecule of this compound, how many oxygen atoms are there?
And
How many oxygen atoms are there?
4.
4. So total how many moles are there? 2 into 10 raised to minus 3.
So,
Right? In one molecule, how many? 4 atoms of oxygen. And in 2 atoms, how many oxygens would be there? 8. Correct?
yes, ma'am.
Yes or no?
Yes, ma'am.
Yeah. Fine. Yes or no?
Yes, ma'am.
So how I'm going to calculate the number of oxygen atoms? Shall I write it somewhere else? Shall I write it here? Number of oxygen is equal to whatever number of moles we get, 2 into 10 raised to minus 3. That need to be multiplied by what? Need to be
4.
multiplied by what? Avogadro number, right? And number of atoms of that particular element present into the molecule. Isn't it? Yeah, that is nothing but 4. So here are 2 moles. It becomes 2 4s are 8 into 10 raised to minus 3 into 6.022 into 10 raised to minus 23. Correct? Yes or no? Yeah.
Yes, ma'am.
Now what you will do here?
Why do you take it as 8 into 10 power minus 3?
What I have taken? Why I have taken 8?
Yeah, ma'am.
Because this 4 2s are 8.
Like
4
why?
is 2
Like
moles.
4?
In
Like
one
from where did
atom,
you get
in
this?
one atom, 4 atoms of oxygens are present. So one
Okay.
element, so one molecule of this C9H8O4, 4 atoms of oxygens are present. So because of that, means 1 mole consists only 4 atoms of oxygen. So like that, how many? 2 moles are here. So 4 2s are 8. Okay.
Okay, ma'am.
Fine. 8 into 10 raised to minus 3 into 6.022 into 10 raised to minus 23. Do this calculation and let me know the answer now.
48 into 10 power minus 26.
10,000 into raised to term, you tell me answer.
Hmm?
In raised to term, you can tell me your answer, right?
And 48.
48 into 10 power minus 26
48
into 10 power minus 26
into 10 raised to
minus 26.
minus 26.
6.
Now you check your answer. Means whatever options are given to you. In that, which answer will be matches with this? That you need to choose. Exactly same won't be there. You just need to move the points here and there. Clear? Yeah. So what would be the answer? Correct answer would be? Come on, tell me. Which one matches with this?
Currently, I can't see the question paper. So,
Achha, you can't see the question. Okay, let it be. Then these questions I'll take it later because I also don't have the question paper in a PDF form with me. Otherwise, I would share with you. Because of that only, I face difficulty. I need to write the question first and then have to like solve it. Fine. I wanted to clear the concept of empirical formula and the molecular formula today. Shall we go for it now?
yes,
Yes,
ma'am.
ma'am.
If you want, I will upload the solutions of this. Okay. Yes or no? If you
Yes,
want,
Okay, ma'am.
you need to wait for it then. I need to generate the copies. But then this answer would be the correct one. You just have to shift your point here and there. Clear?
Yes, ma'am.
Okay. Shall we go for the empirical formula and the molecular formula? Because for the mole concept, we can't invest much time. We have to clear the chapter, and many more concepts are there in this chapter, which are quite important. Yeah.
Yes, ma'am.
Now we are going to see the empirical formula and the molecular formula. See what is given in this. So basically, you should be aware of what is the empirical formula and molecular formula. I'm going to write it here. See, and you have to tell me the difference. What is the basic difference in between for the hydrogen peroxide element? Right? What is the molecular formula for hydrogen peroxide? Any one of you knows? Hydrogen peroxide. Huh? I'm writing HO. And here we're writing H2O2. The molecular formula for hydrogen peroxide is H2O2. And empirical formula will be H and O. What is the difference in this? 2.
Here number of atoms are not represented.
It's the simplest ratio of the atoms, number of atoms present in the molecule, given molecule, right? And here the actual number of atoms present in the molecule, correct? Yes? Yes or no? This is what? Simplest ratio. This simplest ratio will not be true all the time. It will not true all the time. Understand? Means it will not be matches with your molecular formula. Right? Okay. But then molecular formula is the actual ratio of the atom present into the given molecule. Clear? Yes?
Yes, ma'am.
Okay. So see the definition for the empirical formula and the molecular formula is given over here. Once I'm going to read, if you want, you can note it down because it's quite important. The simplest ratio of all the atoms of a different element in a given molecule is called as empirical formula, whereas the molecular formula would be the actual ratio of all the atoms of a different element in a molecule. This is the simplest ratio and this is the actual ratio of all the atoms. And these two formulae are related to each other. How they are related to with each other? By this formula. That is, molecular formula is equal to N into empirical formula. What do you mean by this N? This N we will get when you divide your molecular formula with your empirical formula. Understand? This N is nothing but a simplest integer. Okay, when you divide your molecular formula with your empirical formula, you will get the N. Right? Yes or no? So this is basically a formula or relation in between the molecular formula and empirical formula. Empirical formula is the simplest ratio and molecular formula is the actual ratio of the atoms of different element present into the molecular formula.
What is N? N.
So N is nothing but the simple number, any integer you will get when you divide your molecular formula with the empirical number. Okay.
N is the
How to
simplest?
find it and what is the use of this, that all we are going to see now. Fine.
Okay.
Okay. So there are the certain steps which we have to follow while finding the empirical formula of any of the compound. Mostly what happened, why there is a need to find out empirical formula or the molecular formula in a chemistry chemical laboratory. When we perform the qualitative analysis, we come to know the which elements are present in that particular molecule by performing different tests: carbon test, oxygen test, hydrogen test, right? There is nitrogen test or brown ring test, right? Kind of tests are there. When you go for your 11th and 12th, you'll get to know. When practically you handle these all things, qualitative analysis, you'll get to know about it. So by that, you just come to know the elements present in that particular compound, but then you won't find their exact ratio, right? And to find it, what we have to do? We have to perform these steps to find its empirical formula. And once you get your empirical formula, by knowing the molecular weight, you can calculate its molecular formula as well. Understood? And hence it is very, very important in chemistry. Now, steps to calculate the empirical formula in that, they maybe give you masses. Sometimes masses would be given into the mass of that particular atom. They may give you in a grams, or sometimes it would be given into the percentage. When the mass is given into the percentage, the total mass you have to assume as a 100 gram, and whatever percentage would be given, that you need to convert into gram. Means suppose somebody said like there would be 40% of oxygen is present and 60% of hydrogen is present, right? So this is a compound which consists 40% of oxygen and 60% of hydrogen. That time total mass you have to consider as 100%. That is nothing but 100 gram. Fine. It consists 60 grams of hydrogen and 40 grams of oxygen. Clear?
Yes,
This
ma'am.
is your understood?
Yes, ma'am.
Yeah. Now what is the second step? In a second step, determine the moles of each element. Means you have to find out the number of moles of oxygen, number of moles of hydrogen. Okay, each atoms, each element's number of moles in that particular molecule you have to find. So if the number of particles are given, you can calculate it by the Avogadro number. If not, then molecular mass would be given. You can use it to calculate the number of moles. We know how to calculate the number of moles, and different formulae also would be aware now by the mole concept. So those formulae you have to use to calculate the number of moles.
How do you
Now,
calculate?
yeah, I'm going to give you example also. By that you will get to know. Right? Let me know, explain the all 4-5 steps. Once we have done, directly I'm going to jump to the problem where we are going to utilize all these steps. Okay? Yeah. So number of moles you have to find out. Okay? Of all atoms of element present into the molecule. Third step is what? Determine the mole ratio by dividing each element number of moles by the smallest value into the step 2. Now what is this exactly? I'll let you know. In this, suppose here oxygen and hydrogen, these are the two like atoms present into the given molecule. And you have calculated the number of moles of this. Suppose, assume it, like oxygen has a 2 moles, right? And hydrogen has a 1 mole, right? So which one is the smallest value? This is hydrogen's value is
Hydrogen.
smallest value. Okay, 1 only I have written. Actually, it cannot be possible because 60 gram of hydrogen and 40 gram of oxygen I gave you. Or else I'll give here, suppose it is a 4 and the smallest value would be oxygen's value. Okay. So that time what you have to do, you have to take it, okay, smallest value, and with that all number of moles you have to divide. Understanding? This is for oxygen and this is for what? Hydrogen. What is the smallest value here? 2. With the 2, I'm going to divide to 2, and as well as I'm going to divide to 4. Right? Yes, in the step 3rd. What is the step? Determine the mole ratio by dividing each element number of moles by the smallest value you obtain in the step number 2. Clear? Fine. So in the step number 2, I got the number of moles less in the oxygen, and I'm going to take it and I'm going to divide 2 with the 2 and as well as 4 with the 2. Understand? Means all number of moles, whatever I got for this whole element, I'm going to divide it with the smallest number of moles. Now the 4th step, what I have to do here. If we get a fractional value, multiply it with a suitable integer to make it whole number. Now, by the grace of God, whatever values we are going to get here, that would be the whole number here, right? 2 ones are 2 and here 2 twos are 4. So here we need not to multiply, correct? With any another integer. But then most of the time what happened, you get the values in fractions. Suppose if you get the value 1.5 or if you get the value 0.5, right? That need to be converted into whole number. How you can convert? If you multiply it by 2, it becomes 3. If you multiply it by 2, it will become 1, right? Yes or
Yes,
no?
ma'am.
So in this, you have to convert it into whole number. But then when you do this, you have to do it for all the atoms. You can't do it only for one because our ratio should be same for each and every element, correct? Yes?
Ma'am.
Yes, ma'am.
So I have to do it for oxygen. I have to do it for hydrogen as well. For the means like if I convert the fraction of hydrogen into whole number, with the same number I have to multiply to oxygen as well. So these things you need to keep it in your mind. Okay, and whatever ratio you will get, that would be your empirical formula. Clear?
Yes, ma'am.
Yeah. Easy? Fine. So here is the chart which is given to you. See, first write the symbols of element present in the molecule. This is your first step. Write percentage composition here. If sum of percentage is given is not 100%, then the subtract this sum from the 100 and use it as an oxygen percentage. Why it is so? Because most of the organic compound will not show the presence of oxygen. You have to assume it. Sometimes it may present, it may not present. Suppose they give you the sum of percentage of the different atoms present into the molecule, but then it will not completed with 100%. So all the value you have to subtract from 100 and you have to take it as a percentage of oxygen. For suppose they give you the formula of sucrose. We know the formula sucrose yesterday only we have discussed. That was what? C12H22O11. This is a molecular formula, correct? But then its empirical formula would be what? Its empirical formula?
Ma'am, CHO.
CH
Oh,
O. But then H how many? 2. Correct?
yes, ma'am.
Yes or no? Like this only. Now here, what they have said, suppose you get the percentage of carbon, somehow it will be 40%. This will be suppose 30%, whatever value would be remain. This is what 70% only, right? Total. So 100 minus 70, whatever value would be remain, that is 30, is nothing for oxygen. It would be given, it won't be given. You have to assume it. Remaining value is nothing but percentage of oxygen. Understand? Sometimes they may give, sometimes they may not give. Fine. Now, once you have, means like do this, what you have to do the next? Yes, you have to find out the number of moles. And once you have find the number of moles, you have to take the mole ratio. What is the mole ratio? The smallest mole number you have to use, and you have to divide each and every number of moles by that smallest number of mole value. Understand how we have done for the hydrogen and oxygen in the previous example. And you will get the simplest ratio. If any fraction is there, that you need to be converted into whole number. And once you have converted into the whole number, you will obtain your empirical formula. For understanding, we are going to solve one example. Please write down this example in your notebook. I'll explain you thoroughly about it. See, this is the example. What do you mean by the empirical formula? Find the empirical formula of compound that contains 90.6% of lead and 9.4% of oxygen. Please write down. So here they have given what? Lead.
9.4%.
What happened with this? My God.
Done, ma'am.
So they have given you here Pb, correct? And another one is what? Oxygen O. Percentage of lead is nothing but what? 90.6%, right? And the percentage of your oxygen is equal to what? 9.4%.
9.4.
Yeah. Do the addition, whether it is 100% or not.
Yes, ma'am. 100%.
Correct?
Mm.
Yeah?
Yes, ma'am.
Yes. Yeah. Now what you come to know, it is 100%, means there won't be any another extra atom present in this given formula, right? So Pb percentage is 90.6. So that's why it consists 90.6 grams. Okay, it consists 96.6 gram out of 100 grams, and oxygen is equal to how much?
9.4 grams.
4 grams out of 100 grams. Understood? We have to convert the percentage into grams.
Ma'am, you wrote lead 96.
Right?
90.
Oh, I'm sorry. I wrote 96. It would be 90, correct. Fine, thank you. 90.6, correct? Yeah, this is your first step. What they ask you to calculate in the second step, you have to calculate the number of moles for the PB as well as for the oxygen. And to find out that, you should be aware of atomic masses of PB and the oxygen, both. Oxygen, I guess everybody knows that is 16, but then for PB it is 207.2 gram molar mass, okay, gram molar mass. And the mass would be 207.2 AMU. Okay, PB's atomic mass is 207.2 AMU, and for oxygen it would be 16 AMU. If you convert into the gram, it becomes gram atomic mass for PB. Okay, PB that is equal to 207.2 gram, and here for oxygen it will be 16 gram. This is what again, gram atomic mass of oxygen. Clear?
Yes, ma'am.
What you gonna do? What you gonna do? Number of moles of PB is equal to given mass, that is 90.6 upon 207.2. Do this calculation. Similarly, number of moles of oxygen, that is equal to what? 9.6 upon 16.
16.
Do this and let me know the values. Can you do this division or not?
The first one is 0.437.
First one is what?
0.437.
Very good. 0.437. Okay. And the second one would be
0.583.
0.583.
83.
Are you using calculator for this? No, no?
No.
Oh, you should not. You have to use your logic. See here. 8 to the 16, right? Yeah.
Yeah.
So here 9.6. It's a slightly more than that of 8. So value would be means like near to half. Means 0.5 or something more than that. Isn't it? Like that logic you have to use. Right. Now you get this which one is the smallest value among this? This one, right? PB's value is right. So we are going to take a ratio of it with the number of moles. So number of moles of PB ratio is nothing but whatever mole number we get here, 0.437, that should be divided with the smallest value. This is your third step, right? Here also, what you going to do? Number of moles
0.583 by 0.437.
Yes, 583 divided by 0.437, correct?
Yes, ma'am.
Yeah. So this value would be 1. Yeah. What would be the value?
1.
1 it would be?
This
Check
side.
Mm-hmm.
Moles
What would
of
be?
PD would be
1. Come on, tell me, what would be the value?
1.
1 point something it should be. It won't be 1 only. Because 4 and 5. 4 ones are 4. Again 1 it would be. Isn't it?
Yes, ma'am.
So what would be the value? Check it. It would be almost like this, 1.33. So when you get a whole number,
1.33.
Somewhat around or near about.
Ma'am, it's 1.33 only.
Sorry?
Ma'am, it's 1.2.
1.2?
33.
Yes, 3.
32. Okay, fine. 32. No issues. Okay. Now this is the values. One is into whole number, another is into fraction. Correct? Yes or no? So this fraction you have to convert into whole number, at least near to whole number. For that reason, I have to multiply it by 3. If I multiply it by 3, I'll get what? Values are almost 3.
Like 3.99. 3.99. 3.99.
Yes, I will get a value near about 3.99. And what about this? This will be 3.
3.
Because
3,
if I multiply here by 3, here also I have to multiply it
by
by
3.
Yes, if I have multiplied a number of oxygen by 3, number of lead also need to be multiplied by 3. Okay.
Ma'am, you
So
can
what
take 3.99 as 4.
Yeah. Now empirical formula, what it would be now? How many PB you should take? 3. Correct? And the oxygen would be how many now?
4.
3.99 is nearly equal to how many?
4.
Yes. So your empirical formula would be PB3O4. Got it?
Yes,
You can check
ma'am.
it over here. Check it. It's not on this page. It will be the next page, I guess. Here it is. Check this.
PP3O4.
Isn't it?
Yes, ma'am.
Understood?
Yes, ma'am.
Ritika,
Yes, ma'am.
Jaswant.
Got it.
Okay, fine. So the other one, can you do by yourself?
Okay, ma'am.
Okay, go for it. This one. A student burned the magnesium in a crucible and found that the residue contains 72.93% of magnesium. Correct? 28.02% nitrogen. Calculate the empirical formula.
Okay, ma'am.
Go for it. And there is a relation of molecular formula, empirical formula, and the relative density, specific gravity that I will explain in the next period, because within a period everything will not be happening, correct?
Yes.
And related to that problems also we will continue in the next period. But first of all, you understand empirical formula and how to frame the empirical formula. Okay. Shall I erase it?
Yes, ma'am.
Yeah. I need not to give you hint, right? How to frame empirical formula now. All three of you are able to do that.
Yes, yes, ma'am.
Okay, try it. If you face difficulty, ask me. Purposely, I'm not going to scroll it down because answer would be there on the page. Fine. They have given you what? A student burned the magnesium in a crucible and found that residue contains 72.93 gram magnesium.
Yeah.
Right? And nitrogen would be 28.02%. Calculate the empirical formula.
Ma'am, what is the molecular mass of lead? 24.
Sorry?
What is the molecular mass of lead? 24.
This magnesium you're asking.
Yeah, magnesium.
24 beta.
Okay.
Atomic number is 12 and magnesium atomic mass would be 24 AMU. And for nitrogen, it would be 14 AMU.
Yeah.
Fine. I'll give you just 5 more minutes. And then if you're able to do it, it's fine. Or else I'll explain. Understood about the empirical formula?
Yeah.
Everyone? Okay. So tomorrow we will focus towards the molecular formula and then combine problems of empirical formula and molecular formula. And whatever test problems I gave you, that are really very easy. If you face difficulty, please text me regarding. I'll drop you solutions in the group itself. Okay. Because if same things we will do, we will stuck to that particular point only and we won't get time to complete our content. Right?
Yeah.
Yes or no? Because new concepts we need to clear as earliest. Once all concept would be learned, then number of problems we can solve. Right? So for practice, every day 5 problems I will give you. You try to solve. If you are not able to solve, please text regarding in the group. I will drop the solution for it. No issues. Okay?
Yeah.
Everybody is agree with this?
Yes, ma'am.
Only one student say yes, ma'am. Others, Jaswant and Vedika, I'm
Yes,
not
ma'am.
any sort of communication from you. Why it is so? You should be involved, right?
Today disturbance in my house.
I'm not able to see you at all. I just see your names.
Ma'am,
So
is it MG3O2?
what?
Ma'am, is it MG3O2?
MG3O2 you get? Shall I reveal the answer?
Yes, ma'am.
Okay, fine. I'll taking the cursor down. See, what is the answer? MG3N2, correct.
Yes, ma'am. Thank you.
Yeah, already it comes whole number, right? Almost. So need
Yeah,
not to multiply with anything. Directly you can put the numbers and you'll get MG3N2, correct?
Yes.
Vedika, you got the answer or not?
Yes, ma'am.
Pritam?
Yes, ma'am.
Just one?
Yes, ma'am.
I need to solve or it's okay if not to solve?
Not
Done,
required.
ma'am.
Okay, fine. So shall I continue or shall I stop over here?
Yeah.
Timing would be how much? Till 6:30?
Yeah.
Yeah. So molecular formula, I have to explain you. So do me a favor, just write down at least the step to write, like how to find the molecular formula. If you write the steps, so it will be easy to explain tomorrow. Shall I scroll it up?
Okay.
Purposely, I have took this slow because the steps need to be understood properly. Then only you can do it. Right. Here. Steps to calculate molecular formula. These steps, please write down. Whatever 3-4 steps are given, that only. I won't ask you to do much. Then these steps.
Calculating empirical weight.
Yeah. So see, calculate the empirical weight of the compound from the empirical formula. I mean, suppose they ask you to calculate molecular formula. That time they will give you either empirical formula or directly would be given the empirical formula's weight. If weight is not given, you have to calculate it. And for that, atomic masses you should be aware of. Okay. Then divide its molecular weight by the empirical weight, which gives you the number n. Right? Molecular weight would be given, empirical weight you have calculated. You have to divide the molecular weight with the empirical weight. You will get the value for n. Just we had the formula that n is equal to what? Molecular formula upon empirical formula. This calculation you should do in the second step. Now multiply the empirical formula by its number n. So how you're going to calculate molecular formula? Molecular formula is equal to whatever n value you would get here, that will be multiplied your empirical formula. Right? For example, suppose you have a value over here, our empirical formula for H2O2 would be HO, right? And the value is here 2. N value would be 2 because empirical formula of your hydrogen peroxide would be HO, right? With that, your atomic mass, molecular mass for the empirical formula would become 1 plus 16, that is equal to 17, right? And for the molecular mass would be H2O2. That would be how much? 2 plus 32, that is 34. And n value would be what? Your 34 upon 70, which is equal to 2. So this 2 with this HO. This you would not be aware before, okay? Only this value would be given to you. AMU. Okay? Fine. Now, this 2 would be multiplied with HO. Means this 2 will multiply this hydrogen as well as oxygen. And that you have to write it as a suffix. Right? H2O2. This is your molecular formula. Got it?
Yes, ma'am.
This is a simple example to find out the molecular formula by knowing the empirical formula. Clear?
Yes, ma'am.
Please write down these steps and number of problems we are going to solve regarding by tomorrow on this concept, and few I will post it into the test as well with the empirical formula and the molecular formula. Okay?
Yes, ma'am.
Vedika, just one.
Yes, ma'am.
Yeah, just one. Vedika? Vedika?
Yes, ma'am.
Okay. So few questions I will post regarding this and all of you have to solve. As a homework also I will post few questions and in test also I will post few questions. Fine?
Okay, ma'am.
Okay. Then till that time, take care. Bye-bye.
Bye, ma'am.
Bye. By tomorrow we'll discuss about it.